Hi, my name is Dana Golden. Today we're going to run through the KMeans code. So we're going to run import numpy as np, import matplotlib as plt from sklearn.datasets, import make blobs. So this is KMeans, and we're going to start off by creating our dataset. Recall that KMeans, the idea is that you have data that is set up in different clusters, and then you pick individual points, and then basically you change the centroids until you have a stabilization of clusters. We're going to do a loop that basically is going to change where the center of these clusters are until we have convergence into two clusters. This is a clustering algorithm, which means that we're going to do this on data that are not labeled. So the data have no labels. We're going to have to make the labels ourselves. So this is unsupervised learning. So we create our data, make blobs. We create class KMeans. We create the number of Ks. You can choose the number of Ks using what's called an elbow curve, meaning that you look at the error and you see where it starts to go down. So where it starts to taper off in terms of the decrease. So 4 would be the example here. So max iters, this is the max iterations. We're not going to start off with these centroids. We'll randomly choose centroids. We're going to assign labels to the centroids using this assign labels function. So we're going to choose labels based on where there's the minimum distances. And then we're going to calculate the centroids of the newly labeled points, and then we're going to check for convergence. K-means is guaranteed to converge because the distance between points cannot continue to decrease forever. Eventually, it has to stop decreasing. So if you'll notice, K-means is non-unique. So if we run this a bunch of times, we could, in theory, get different outcomes for these x's are. So these are different clusters, and as you can see, each cluster identifies a different set of points. With this purple, maybe this is actually in yellow. Maybe some of these blues are actually in purple, but overall it does a good job of trying to distinguish out where the main clusters are. And now let's do it with sklearn. So we're just going to, from sklearn.cluster, import KMeans. sklearn KMeans equals sklearn KMeans, number of clusters equals 4. And then we're going to do it again on this data. Let's see what happens when we do number of clusters equals 3. So notice this blue has combined, or this purple has combined with this yellow. What happens if we do number of clusters equals 2? So we're probably going to end up with the blue on its own and then a purple away from the blue. And then if we do number of clusters equals 1, what do you think is going to happen? We're just going to get a big blob. You could do bigger and bigger numbers of clusters. And you can see how if you make the clusters large enough, basically everything becomes its own cluster. This is one of the reasons why you shouldn't choose larger and larger clusters, because if you shouldn't try to at least minimize the error. So remember, K-means is about the within sum of squares and the between sum of squares. And you're minimizing. You're trying to get the between sum of squares to be the smallest. You're trying to minimize the. You're trying to maximize the distance between different clusters and minimize the distance within the clusters. So here, we're trying to separate the clusters as much as possible. Well, you could just do that almost automatically by choosing a number of clusters that is equal to the total number of points. So that's really not desirable. Here we have k-medioids, which is another mechanism for doing k-means. K equals k, self.max others equals max others, medioids equals medioids. So we initialize the medioids based on the points, and then we assign labels. We calculate the medioids again. So here we're basically calculating the median point. So this kind of works as a way to prevent overfitting, because the idea is that if you have points that are way off, you don't want them to affect the assignment as much. So we run k-medioids. So notice cluster points equals, you're choosing them from labels, you're choosing the medioid of the cluster points. Run k-medioids with k equals 4. We get these clusters. They're about the same as the earlier ones. In theory, they might be a little bit less susceptible to outliers. So yeah, so now let's do k-medioids again. And here we go. Nicely enough, outliers are not as big an effect here. Let's do 10. And notice, because it's a clustering algorithm, sometimes it takes a while to converge, because it's really doing that iteration. Here we've done it with max iterators. You could also do it with a while loop, where you're waiting for it to fully converge. That can take some time, but it's also probably what you want to do in the real world. Thank you. This is how you can get some clusters. This is usually used as an initial technique for data visualization and data exploration, but not always. Sometimes you really do want these clusters. Sometimes that really is the end result. Thank you, and I hope you have a great day.